Fundamental theorem of algebra says every function defined by a polynomial of degree 1 or more has at least one complex zero. And the number of zeros theorem says a function defined by a polynomial of degree n has at most n distinct zeros. Most of the time we think of it in kind of a overly simplistic way, but usually if I see x squared, I'm thinking there are two zeros. Okay, complex, and if that's a 21, I'm thinking there are 21 zeros. I may or may not be able to find them all, but they might be real, they might be non-real, they might be rational, they might be irrational, but that's kind of what I'm thinking. 4a says find a function f defined by a polynomial of degree 3 that has zeros of -3, -2, and 5, and f of -1 equals 6. This is the piece of information that makes it a little bit harder. Okay? When you see them, when they give you the zeros, okay, we know a zero of -3 means there's a factor of x plus 3. And a zero of -2 means there's a factor of x plus 2. And a zero of 5 means there's a factor of x minus 5. Everybody should be good about that. Okay, everybody should be good with that. So if we want a polynomial, you would think you just FOIL that all together. Okay, and that's kind of what we're going to do. We're going to FOIL all that together and see what we get, and that's going to look like a polynomial. So let's do that. I'm going to start with, well, let's do these two. That's x squared minus 5x plus 2x minus 10, or x squared minus 3x minus 10. But now I'm going to do another distributive property. I'm going to have to distribute that x plus 3. So give me x cubed minus 3x squared minus 10x. And in here we get plus 3x squared minus 9x minus 30. I like writing it like this, so I line up my like terms. I think it's easier to do. You've got x cubed, these cancel out, so minus 19x minus 30. Now, it would be nice if we were finished, because that sure looks like a polynomial of degree 3, and that's what they asked me for. That is a polynomial of degree 3 that has those zeros, but the problem is, and there will be some of you that will skip this, we haven't used this information in any way. Okay? Generally, we're going to want some sort of coefficient number in the front here, and that coefficient number is what's going to force me to get f of -1 equals 6. Okay, so I have to have a polynomial that produces that information. In other words, if I plug in -1, I get out 6. I bet that's not going to happen. If I plug in -1 right here, I'm not going to get out 6 because I haven't forced that to happen yet. Okay, so what we're going to do is this. We're going to say f of x equals, and we're just going to put a coefficient a in front of what we just got. Okay? And basically, if we let x equal -1, we're going to get f of -1 equals 6. So I'm going to plug that in. So if x is -1, that's going to give me 6 equals a times whatever I get when I plug in -1. So you can do that on a calculator if you want, but we're going to have -1 to the third minus 19 times -1 minus 30. That's -1 plus 19 minus 30. That's -12. -12. So I've got 6 equals a times -12. All I did was plugged in -1, set it equal to 6, and I'm trying to figure out what that a value is. So, okay, divide by -12. A equals 6 over -12. A equals -1/2. So then my function, if a was -1/2, all I would need to do is distribute that negative 1/2. Okay? Distribute that negative 1/2, and I'm going to get f of x equals negative 1/2 x cubed plus 19/2 x. And then half of 30 is 15, so plus 15. Now I have a polynomial of degree 3 with those zeros that they required and the special stipulation that plug in negative 1, you get 6. Negative 1/2 x cubed plus 19/2 x plus 15. (4b) is pretty much the same question. Find a function f defined by a polynomial of degree 3 that has a 0, 4 of multiplicity 3 and that same bit of information. Now, here's the new part, I guess. Multiplicity means repeat. Okay, so we have a 0 of 4, which means x minus 4, but that x minus 4 repeats itself 3 times. So essentially what you've got then is x minus 4 3 times. That gives me a 0 of 4 with multiplicity 3. It just means it's repeated. So we're going to multiply that out. So let's multiply that out. That's x squared minus 4x minus 4x plus 16, or x squared minus 8x plus 16. We're going to do x minus 4 times that. So distribute, that's x cubed minus 8x squared plus 16x. And then minus 4x squared plus 32x minus 64. Which gives x cubed minus 12x squared plus 48x minus 64. Now again, some people are going to try to stop there, okay? But you can't stop there because we haven't used this piece of information yet. So in order to use that information, I'm going to say, f of x equals a times that stuff. But more specifically, plug in the numbers. Okay, if I plug in, I'm plugging in 2 this time, right? You're plugging in 2 this time. F of 2 is negative 24, and that's going to equal a times whatever you would get. 2 cubed minus 12 times 2 squared plus 48 times 2 minus 64. By all means, use a calculator. When you plug all that in, when you do all that math, you're going to get negative 8. Negative 8. So negative 24 equals a times negative 8. We want to ISO the variable, so divide by negative 8, and a equals 3. A equals 3, so that's the coefficient that goes in front of that entire function. F of x equals 3 times that stuff. So distribute 3x cubed minus 36x squared. 48 times 3 is 144, so plus 144x. And 64 times 3 is 192, so minus 192.